All right, it's 10:40, so it's about time we get started. I kind of have a lot of stuff to get through. So let's see, can everybody hear me okay? Okay, great. My name is Mark Sadecki. I'm the accessibility coordinator at edX. We're going to talk to you a little bit today about developing for accessibility. So my favorite definition of the word accessibility is the degree to which a product, device, or environment is available to a person. I like to think of accessibility as a relative term. Something that's accessible to me may not be accessible to you, and vice versa. Some things are directly accessible to a person. That means they just work out of the box. You can just pick it up and start using it. And some things are indirectly accessible. What that means is that a person uses some sort of assistive technology to access that device or product or environment. Conversely, something that's inaccessible has been designed to be inaccessible despite the availability of assistive technology. So I introduced a word in there that may or may not be familiar to you, assistive technology. Even if you're not familiar with the word, you're probably familiar with some examples of assistive technology. So assistive technology, oh, my slides aren't advancing, are they? Let's see if we can fix that. Whoops. There we go. We're all synced up now. All right, so we talked about directly accessible, indirectly accessible. Okay, assistive technology. These are tools that people can use to bridge the gap between, to bridge gaps that they have in their ability to access a product or a device or an environment. They allow people to do things that would either be very difficult for them to do or impossible. Assistive technology can enhance or change how a person interacts with a product, device, or environment. Earlier I said that many of you are already familiar with assistive technology. Up here on the screen I have a few examples of some common assistive technology that people use. People who are hard of hearing may use a hearing aid to amplify sound or even feed it directly into their auditory processing nervous system. People who don't have the strength or control of their lower extremities can use a wheelchair. I also have a picture of one of those buttons you can push to automatically open a door. That's an example of assistive technology, and it's probably one that we've all used, even though we may not require it. I also have a picture of a curb cut. Again, something that we see in the built environment every day that is specifically designed to allow people who are wheelchair users to quickly get up onto a curb. But it also benefits mothers pushing a baby carriage or, shoppers pushing a shopping carriage, for instance. Believe it or not, an iPhone is a piece of assistive technology. It can be used to identify money, to identify colors, to read, magnify, and translate printed text. All features that benefit someone who cannot see or see very well. I also have a refreshable braille display and a white cane up there. These are all typical examples of assistive technology. They bridge that gap. Prosthetic limbs, custom keyboards, software like screen readers, screen magnifiers, and speech input, speech-to-text software are also considered assistive technology. So earlier I said that inaccessibility was when we build things, software included, that are incompatible with assistive technology. It would be impossible for me to cover everything that we as digital content producers and software engineers need to do to make our content and tools accessible. So what I wanted to do today was to cover some basic concepts that help you identify where barriers might be introduced and different approaches you can take to make your digital content accessible. So before I do that, I want to fundamentally change the way we think about accessibility. Traditionally, accessibility has been used in the context of people with disabilities. But what I hope to demonstrate here is that everyone benefits from a well-designed quality product, designed to be accessible to as many people as possible, just like the curb cut and the doors that open automatically. We have all appreciated a well-designed product. It's a product that feels solid, it's intuitive to use, it includes clever redundancies and shortcuts that allow us to use the product more efficiently, and offers us a choice of how we use it. I like to hold the iPhone up as a shining example here. When touchscreen devices first hit the marketplace, people who couldn't see, who rely on speech and tactile interfaces, were terrified that they would be left out of the next stage in the digital device evolution. But thanks to incredibly thoughtful and innovatively designed software interfaces, Apple engineers made a flat piece of glass one of the most accessible digital devices ever created. Earlier I mentioned various types of assistive technology or assistive technology needs, like the ability to identify printed money or colors. These are all before the advent of the iPhone or any accessible platform, mobile platform. People who couldn't see had to carry around all these different devices. They would go to a store if they needed to pay for something. They'd have to pull out a currency identifier and they'd have to feed their bills through it, and it would tell them this is a 5, this is a 10. Now they can literally just wave their phone over it and they can find out if it's a 5 or a 10. They used to have to carry around color identifiers when they were getting dressed in the morning to figure out what color shirt they were about to put on, make sure it didn't clash with their pants. Barcode readers, literally dozens of devices they've had to have all over their home in order to just live out their everyday lives. With an iPhone, because the product itself is so accessible, they now just have to carry around this one little single device. And it wasn't a device that was designed specifically for them. It was just a mainstream device that everybody else used that accomplishes all of these goals because it was thoughtfully designed. So iPhones are in the hands of nearly 70% of all blind smartphone users because of this. I think that in order to start building better software that's accessible to as many people as possible, it's important for us to understand the myriad ways that all people interact with our digital devices and software. How we interact with digital devices hasn't changed since their inception. It's as simple as input and output. The problem arises when we build software for the typical computer user. Many of us in this room are typical computer users. We click icons with a mouse, we touch controls with our fingers, we type text with a physical standard keyboard, we scroll pages up and down with our mouse or a trackpad, we read text with our eyes, and we listen to audio content with our ears. When designing digital products, we often design it to our ideal specifications. Because people who design and test digital products are often very typical users, the products often only meet the needs of typical users. When this happens, you end up with a product that's really only accessible to people who will use the product just like we do. To move beyond this and start building high-quality products that are accessible to as many people as possible, we must first understand other ways that people interact with our stuff. So the problem starts when I have to do my project spreadsheet in 10 minutes, apparently. Okay, so the problem arises when we build in support for just too few means of input, like just our mouse, and when we have to support far too many forms of output, like images, video, audio, PDF, spreadsheets, and simulations. That's not to say that we can't do that, but there are certain considerations we have to make. So the solutions are support for the keyboard, for input, and to text all the things, or provide text equivalents for output. Everyone always thinks accessibility is so hard. So the solution to the input problem is a relatively easy one. There are literally hundreds of assistive technology designed to give users alternative means of getting data into their computers. But nearly all of them share one particular thing in common. They're either custom modified keyboards or they emulate a keyboard. There are even a range of common disabilities that make using a mouse either not worth the effort or not possible to use at all as an input device. So keyboards and keyboard emulators are the only means of input for these users. When we design our software applications, we must ensure that all the features are accessible and all controls are operable using a keyboard. Or a keyboard emulator. We don't need to test with a keyboard or a keyboard emulator. The one on our desk in front of us will do. In addition to ensuring that everything can be accomplished with a keyboard, we need to ensure that we use well-established keyboard controls that act in predictable ways. Lots of assistive technology software use various keyboard controls and shortcuts that allow their users to interact with the computer more efficiently. So for instance, JAWS, one of the industry leaders of screen readers, has over 400 keyboard shortcuts that the users can use to efficiently interact with their computer. So we can't start making up our own keyboard shortcuts to all of the custom widgets and devices that or software controls that we're going to build. So what you want to make sure you can do is you test your feature with a tab, spacebar, return, and arrow keys. Okay, these are off limits to assistive technology. They know that they're not going to touch these. And if you can do that, you can build your custom controls to support keyboard navigation, then you're well on your way to making your app accessible to nearly everyone. The solution to the output problem is just as easy. We need to make sure that we either publish our content as text or provide a text equivalent. I get a little excited when I talk about text. Computers are really good at working with text. Software can be used to transform text into speech that blind people can hear. It can output the same text as Braille that they can touch with a refreshable Braille display. It can be translated into other languages that open up volumes of information to people who don't speak or understand the primary language of the document. This is hugely important to this particular community because edX is an international platform. Okay, it's used all over the world. We have learners on edX.org, for instance, from just about every country, speaking just about every language. And unfortunately, our content isn't always available in all of these languages. But if it's available as text, it can easily be translated with the click of a button with modern software. Text can be enlarged so that those with low vision can easily read it. Users can customize the colors and the size of the text. We can use text, also known as markup, to imbue almost magical powers and qualities to other text. Text can be processed by machines. Don't get me wrong, computers are getting better at understanding images too. But until Google stops seeing chihuahuas in your spaghetti and meatballs, it's going to be up to humans to create useful text alternatives for images. This is an example of Google's inceptionism algorithm trying to figure out what this plate of spaghetti was. Okay, accessibility at edX. So, as I said, I don't have enough time to go into all the details of making your content accessible or your open source contributions, but I can tell you a little bit more about what we've done so that you don't have to worry so much about accessibility here at edX. So the edX Accessibility Initiative is not a new initiative at edX. We've been requiring that all videos published to edX.org include text transcripts so that learners with hearing impairments can access the content. We've also had outside accessibility consultants perform 2 separate audits on our platform and to identify accessibility barriers and to let us know what we have, where we have room for improvement. Accessibility is becoming a legal requirement in many parts of the globe, and we know it's important to our learners, our partners, and the open edX community. Our commitment to accessibility is also pervasive in our goals, our values, our vision, and our mission. So up here I pulled some quotes from our goals and our vision and our mission. You can see that the word everyone appears throughout our goals, values, and mission. The word everyone is by definition inclusive. It includes all humans, regardless of their gender, class, creed, age, nationality, sexual orientation, or ability. So in 2014, edX decided to take their commitment to accessibility to the next level, and they hired a accessibility specialist. That would be me. And then on April 2nd, 2015, we defined a formal accessibility policy. We thought that was a good cornerstone to launch our accessibility initiative. It outlines our commitment to making our website, our mobile applications, and our software platform accessible to individuals with disabilities, and to make sure that content providers can create accessible content. We decided to choose the Web Content Accessibility Guidelines, also known as WCAG 2.0, level AA, which was published by the World Wide Web Consortium, as the standard to which we would strive for. The policy is posted on our website, right in the footer, and was distributed to our partners, staff, and contractors on that date. Next, we created multiple mechanisms for soliciting feedback from our learners. We formalized a process for handling support requests that came in from users with disabilities. We've created a comprehensive documentation with regard to publishing accessible content and guidelines for making accessible open source contributions to the platform as well. We've trained every single one of our staff and made training part of our onboarding process. We continue to schedule annual outside audits and have a formal process in place for finding and fixing accessibility bugs and ensuring that all new features comply with WCAG 2.0 level AA. So, measuring compliance. If you're wondering how we settled on WCAG 2 level AA, it's because the Web Content Accessibility Guidelines are the gold standard for measuring accessibility of web content and applications. They've been adopted outright by 9 countries as law, and 6 others have created their own guidelines based on WCAG 2.0. The United States hasn't passed any new legislation regarding the accessibility of web content since 1998, when they passed when they added Section 508 to the ADA. But a new version of Section 508 is currently out for public comment, and it directly incorporates and references WCAG 2.0, so we don't expect it to be very different. The 508 refresh, as it's called, is expected to become law very soon, as soon as it gets through the rest of this formal legislation process. If you're not already familiar with WCAG 2.0, it's a set of guidelines that are divided up into 4 core principles. Perceivable, which means that your web content can be perceived by at least one of the human senses. This is why I get really excited about text, because text is easy to transform into something that can either be seen, felt, or heard. The interactive controls can be operable. It's the second core principle. Again, super excited about keyboard controls because almost everyone can use a keyboard or a keyboard emulator. Understandable, that your content is understandable means that you've used markup correctly to convey content structure, the role that any given piece of text or interactive control plays in a page or an application, the state that it's in, and any other properties that the text may have that is being conveyed visually. It also needs to be conveyed through markup. And robust, which means that your content and features are robust, means that they are accessible on a wide variety of current and future devices and platforms. The best way to ensure that is to use standard markup, okay? Things that, code that validates to any given standard. Okay, WCAG 2.0, these core principles are divided up into 12 individual guidelines, and those guidelines are divided up into 65 testable success criteria. Of the 65, 38 of those apply to level A and AA, so that's what we're testing against. Engineers usually get pretty excited when they hear that success criteria or testable statements. However, not all of the success criteria can be tested automatically, and some still require human verification. Many of the criteria that must be met are dependent on the context in which they appear and the quality of the solution. Both of those are very difficult, if not impossible, to test automatically. However, a fair amount can be tested automatically, and we have recently just added accessibility tests to our testing framework that can run on code that's submitted to the edX repository. All right, we're getting near the end. We understand that not everyone here is an accessibility expert. We'll continue to do our best to make our website, the Open edX platform, and our mobile apps accessible. And we'll also pledge to support the Open edX community in creating accessible content and making accessible open source contributions. To help you accomplish that goal, we've created some documentation on docs.edx.org. The first is for authors. It's a accessibility best practices guidance for content providers. This helps you create accessible content using Studio. We've created a set of accessibility guidelines for developers. Again, this should help you create accessible open source contributions. And we recently trained all 183 of our staff and contractors using a course that was built in edX. It was really tailored for this specific group, but we're working on creating a more generally applicable course that will be available to the general public soon. So up here I have some links to our accessibility resources. We have the best practices guide for content providers I just spoke of, the accessibility guidelines for developers, and some documentation on creating automated accessibility tests for the edX platform. I also think we're going to try to hold a unconference talk this afternoon about the accessibility testing, if you wanted to come to that session later. That's it. Questions? Yes, in the back.
So the course that you mentioned, the training course on the edX platform, that currently have some accessible internally?
Currently, exactly. We literally just finished it up a couple of weeks ago, and we're working on making sure it's applicable to the general public. Yeah. Question?
How do you see these standards evolving as new technologies and new standards come out in this field? I know this is a moving target.
Sure. Sure. So it's a moving target, but progress on the standards is always evolving. The W3Cs they don't stop. They keep coming out with new iterations. Every single standard has a editor's draft that's up to date. They still meet every week to talk about the evolving standards. I know there's a new version they're working on. ARIA is the Accessible Rich Internet Application Standard, and that is 1.0 was recently published about a year ago now, and they're working on 1.1 already and already talking about 2.0. So yeah, I mean the standards are going to evolve. Our goal as developers is to build software that works for everyone. So, you know, staying up to date on the standards and testing your software is really, you know, all that we can do. But I do think that the place to start is to always be reading the standards. Yeah. Yeah. Sure. Right. I get this question a lot. I think that if, again, you want to make your software accessible to as many people as possible, and if you start your project with that goal in mind, you'll find that most of the problems that are introduced during the development process. And there are very few controls or interactive type control widgets, let's call them, that I feel cannot be made accessible. I really think that if you start thinking about the challenges from the beginning, and it's really as basic as input and output. Asking yourself, how would somebody who doesn't have access to one of the particular senses be able to perceive this, and exposing it. It's interesting. A lot of times I start out with very simple challenges, like sometimes it's about, how can I create alt text for an image that doesn't give away the answer to a particular question. It might be, let's just throw out a simple example. You have a picture of a square and a circle and a rectangle, and your question is to pick out the triangle. And somebody's like, well, if I put alt text that says triangle, square, the answer's in the alt text. Well, don't put that in the alt text. Just put a 4-sided object, a 3-sided object, and describe ask yourself, what does somebody who can see this, what are they looking at, and then just describe that in words. So the solutions are often creative, but I do believe that all those problems can be solved. Okay, I think that's it. Thank you.